Okay, so this is your continuation from your forefers. This is a forefer with one-step algebraic equations. This time there are no constants in our equations. There are just coefficients. So the first question says 2x equals 8. And what we have to understand is this really says 2 multiplied by IED, oops, multiplied by x. 2 multiplied by x. And if we see it as being multiplying by 2, we understand the opposite operation to that is dividing by 2, and I get x equals 4. So in the second part, we have the exact same question here. It says 2x is equal to positive 8. So once we have our x's on one side of the equation, we can actually draw two separate scales and divide those x's equally among two smaller scales. So if 2x has the value of 8, then each x, we're going to divide those equally over here. Each x would therefore have a value of 4. So from a modeling perspective, if two x's have the value of 8 or the weight of 8, then each x must have the weight of 4, where x equals 4. In the second example, the only difference I have is I've put my x variable on the right-hand side instead of the left-hand side. But our goal is still to isolate that x. And right there it says 4 times x. So if I'm multiplying x by 4 and then dividing it by 4, those will cancel each other out. And whatever I do to one side, if I do to the other, x is isolated. Negative 4 divided by a positive 4 is negative 1. So our value is x equals negative 1. In the second example, it's the exact same question, but since I have my 4x's here, I'm going to divide them into 4 mini scales, put 1 on each of them. And if I divided that side onto 4 different scales, I'd have to divide this side equally amongst those 4 scales, and I would have each x has a value of negative 1. X equals negative 1 or negative 1 equals x. They're the same thing. In the second example, in the third question, I should say, we have x over 2 equals 3. What this actually says, x divided by 2 is 3, So we think of x divided by 2, the opposite of divided by 2 is to multiply by 2. So what I'm going to do is I'm going to put a bracket with a 2 there and a bracket with a 2 there. And what I mean by that is I'm doubling both sides. So instead of having half an x, I'm going to have all of x, and 3 times 2 is 6. Now this is best illustrated when we actually do the modeling, because right here, what I have here is half of an x, half of x, or half of x, or half times x, or as a decimal, half times x. Or finally, just taking x and dividing it by 2. So this, 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 and this are all the exact same thing, including this. Everything I've just circled there, all 6 items mean the exact same thing. Whatever the value of x is, half of x can be interpreted those 6 different ways. Okay? So what we're actually going to do here is if I was to double this side, so if I had, instead of 1/2 of x, I had 2/2 of x, that would actually make 1 full x. And instead of using the stick this time, we're going to use a thicker, fatter stick. But if I doubled this side, I have to double this side to make sure it keeps it equal. So it was 3, but now I'm going to put 6 down. And what I have here for an answer is x equals 6, okay? Which is the same answer I had over here. Okay, I just have to think about this as being half of x or half of x. All right, that's the important part. That's the connection. In the final question, we have negative 4 equals x minus 3. I'm first going to do the modeling first. So I'm going to do this one over here. And if I look at this thing here, I'm going to ungroup this. If I take this, oh, not that. If I take this and I group it and I infinite clone it. If I double it and I triple it. If I triple that side, I would have 3/3 of x, and 3/3 is also known as 1. So I would have 1x if I tripled that side. But if I triple that side, in order to maintain equality, I'm going to group this side, and I'm going to infinite clone it. I have to triple this side to maintain equality. And what I end up having here is a full x because those 3/3 make a full x, equals 12 negatives, or negative 12 equals x. Okay. If I look at that exact same question up here, but numerically, I'm going to move these over a bit. If I multiply this side by 3, that's exactly what I did right here. Multiplying that side by 3 is the exact same thing as I did in the modeling because I tripled that side. So multiplying it by 3, instead of having a third of x, I'll have a full x, or 1x. But I have to multiply this side by 3, and 3 times negative 4 is negative 12. Same answer. Okay, those are all one-step algebraic equations with just coefficients. The new learning is probably this idea here of reading it as being half of x, or half of x, or half of x, or half of x, or half of x. Okay, hopefully that made sense.